In no way is this any different from what you were just doing. It's just that here you'll find infinitely many or no solutions. So what happens once you combine these equations is going to be a little bit different. The instructions still say to use substitution, so we could check it with a graph if we wanted, but if this were a quiz or test, your teacher is basically going to grade you based on using this approach. Rewrite the problem as it is, and by this point the assumption is that you feel a little bit more comfortable having seen a bunch of those. So I'm going to jump right in. Just like in the other ones, I'm setting up 6x minus 2, but I'm going to substitute in this portion for y. So here's 3x plus 2 equals 4, which means that we'll get 6x minus 4 equals 4 because this got distributed. You can imagine these would be your typical common mistakes that you could make. So then on the left side, these terms get canceled out, and you're left with negative 4 equals 4. And no, this doesn't mean that you made a mistake or anything. What this means is that negative 4 does not equal 4, and your prediction is either that it's no solutions or infinite. And whenever you get something that is false, that means that it's a no solution. Were I to go ahead and solve for y in the first one, I would get a line where y is equal to 3x plus 4, which means that these two lines have the same slope but different y-intercepts, so they would be parallel, which means they never run into each other. So as you're dealing with more challenging problems that maybe you can't just test without looking in the back of the book, maybe you can try to graph it and think about it that way to help you better understand it and to check your work. Look at this one just for a moment and see if you can figure out what's mildly tricky about this. The only thing that I see that makes this different is y is shown in the first part here, whereas x is shown in the second part there. So you just got to keep your eye out and make sure that you don't get that tripped up. So when figuring out what's easiest to deal with, no matter how you approach this, you're going to be stuck dealing with fractions. So let's just take this second equation here. And we'll solve this for y. I'm adding 8x to both sides, which leaves me with 6y is equal to 8x minus 2. Dividing everything by 6, we'll get y is equal to 4/3 x minus 1/3. It came from the second equation, so we're going to plug this into 4x minus 3y equals 1. Now I'm going to substitute in what we found out for y, which is 4/3 x minus 1/3. And we're going to see if that's equal to 1. What usually will happen is as we distribute, we luck out and the 3/3 cancels out, leaving us with 4x. And again, the 3/3 cancels out, leaving us with plus 1. These terms go away, and since 1 equals 1 is a true statement, this means you have infinite solutions. And what this would tell you graphically is that both of these are the same line. (2x minus y equals 8, y equals 2x minus 3. Just like the previous ones we did in the last set of videos, I think that we're going to be able to jump right in. I got 2x minus y, which I'm substituting 2x minus 3 in to replace. So I get 2x distributing the negative, flips the sign on everything on the inside there. and then it says 3 equals 8. Since this is not true, you would say, well, no solution. Same as before. I mean, we could rearrange this, and our line would end up being y equals 2x minus 8. And if I look at the slopes of these equations, they have the same slope with different y-intercepts, so they would never run into each other, so there's no solution. So just to kind of go back to the very beginning of this, there's nothing crazy new here compared to the last video. The only thing that's different is whether or not you're going to have infinite or no solutions. If you get a statement that is true, then that means you have infinite. If you get a statement that is false, that means you have no solution. And there's no need to graph these, but that is a tool you can use to check to see if answers are correct. Another thing is, as these are new ideas, you could plug these into Wolfram Alpha. You could call a friend and see if you get similar answers. Plugging in the first one was mostly straightforward. Dealing with the second one had fractions, and I think that this took the least amount of challenge of all of them.